Hi there, this is Tyler Taldone, representing the demo for Lab 4, the Simon code, and I just wanted to give you first a quick little walkthrough of the code. Um, Actually, first I want to talk about the debouncing choice. After spending a large amount of time trying to use a software debounce, uh, I arrived at the conclusion that it's more efficient to use hardware debouncing than software debouncing, because to employ software debouncing you'd need to call the interrupts twice as often or poll it, both of which would consume almost double the amount of power necessary. In contrast, the hardware debouncing would just form from having a capacitor added to the circuit and would be a very small initial purchase compared to the overall cost. Therefore, I used hardware debouncing over software debouncing. So let's walk through some of these variables that we're going to use in our Simon code. We got the randint, we got the push number, which is how many times you press the button. Lose is the game state for when you lose. User timer is used as a sort of thing that's going to give a certain number of clock cycles. So it's like a time period for the user, how long they have to input before they lose. Valrand is a random value generated from the randint. I is an incrementer, and seed is something that comes from when the user actually pushes the button in relationship to when the timer starts. So that increases the random ability. So first we set up the pins. I was originally working on the onboard pins, which is why a lot of this code still has bit 0 plus bit 6, and so it will still work even without the circuit board, but right now I have it hooked up to the breadboard. So we enable the pull-up resistors and put them into outputs and interrupt enable it. Next we set up the timers, which for timer 0 we have the small clock selected, continuous mode, and divided by 8. Timer 1, small clock, submain clock is selected, up mode, and divided by 8 too. We give some initial values for CCR0, so that acts like a counter in the code. Then we do some flag setting and enable interrupt, and then we hit our first timer vector, and this basically controls the rules of the game. So first it checks if we're in the losing state, which, for the first time it hits it, it won't happen. In the losing state, it'll blink a pattern continuously. Next we have the user timer, which acts like a timer for, it counts how many cycles have passed since the user has made an input, and if too many cycles pass, then it checks whether the right number of button presses match the value of the random generated flashes, and if you didn't, then you enter the lose state, which was above, so then it would start flashing. And so if this like wait counter is equal to 0, then then it's like we're in the start state, and we initiate it by flashing a certain amount of random flashes, which we do by our randint, which we'll get later. And so if after that happens, make the number of pushes that you have equal to 0, and set it back to where it pays attention to that, and then we increment the timer to be used later. So our randint, we used a timer A1 register, which is cycling so quickly that it's the last 2 bits are practically random. And in order to increase the randomness, we also kept a seed, which would be recorded from when the user how long the user actually takes to put in his response, so that would be pretty random. And then we masked it and ANDed 1 in order to get it from 1 to 4 inclusive. Next we have what happens when you push the button, the port vector, and what happens is to make sure that no input is collected while it's flashing its pattern, we have this if statement. And then we also have this if statement, which would, if you're in the losing state and you want to reset it to play again, all you have to do is press the button 1 more time. So now I'm going to program it, and we're going to see a demo of me doing it. So I'm going to press play. Alright, here we go. 2, 3, 1, 2, 3. 1, 2, 1, 2. 1, 2, 3, 4. You know, it's not too difficult, but you know, it's a pretty fun game, and I'm very happy with how it turned out. 1. I'm not sure how many times I have to show that it works, but I'm going to keep doing that, and then I will make it lose. And as you can see, it's entering the lose state. Now I am going to press it once more, which should reset it, and so now we're playing the game again, 1, 2, and this time I'm gonna not answer it, and since it goes over the time limit, it will go into the game state. Whereas last time I pressed the wrong number of buttons and it went into the game state, into the losing state. So that's how the game works, and I'm very proud and can't wait to see it implemented on a PCB board. Thank you.